Every first degree equation in x comma y represents a straight line. So let us begin by considering a curve whose equation is a first degree equation in x comma y. Because it's a first degree equation in x and y, what we'll do, we have considered this particular equation ax plus by plus c equals to 0. Now what we'll do, we will consider 2 points that lies on this particular curve. Let those 2 points be P and Q with the coordinates x1, y1 and x2, y2 respectively. Now because these 2 points P and Q lies on the equation of the curve, or you can say it simply lies on the curve, it must satisfy the equation of the curve. So this must implies that we have ax1 plus by1 plus c equals to 0. This is going to be one equation, and we are also going to get the other equation ax2 plus by2 plus c equals to 0. So let this be equation number 2. So what we have here is, graphically, if we want to understand, we have a point P with the coordinates x1, y1. We have another point Q with the coordinates x2, y2. And these 2 points lie on a curve, let's say P, where we've joined here P and Q. So this is a portion of a curve. Now, since we want to show that this is a straight line, so we'll assume that, to begin with, we'll assume this is a straight line. And what we'll consider? We'll consider a third point R, which is going to divide this curve into 2 segments, lambda is to 1. So here R is dividing the line segment PQ in the ratio lambda is to 1. Although it's a curve, we are assuming that it's a straight line for the time being. So if it is dividing it in the ratio lambda is to 1 internally, what we can do is apply the section formula to obtain the coordinates of point R. To obtain the coordinates of point R, all we have to do is take lambda and multiply it with Q. 1 will get multiplied with P. Meaning, if we start with the x coordinate, then to find out the x coordinate, we'll take lambda and multiply with the x coordinate of Q. And then add it to 1 times the x coordinate of P, so we have x1. Divided by the sum of the ratios, so we have lambda plus 1. Then for the y coordinate, we have lambda times y2 added to 1 times, this is y1. Added to the y coordinate of P, so we have y1 divided by lambda plus 1. Right. So this is how we can define the coordinates of point R. In the next step, although we have assumed that R lies on the point and it divides PQ into ratio lambda is to 1, we will now check for sure that R actually lies on the line. So how do we check that? In order to check that R definitely lies on the line, we will assume, so let R actually lie on the line segment, or you can say the curve, lie on the curve, which is a line segment actually, lie on the curve joining PQ, then it must satisfy the equation ax plus by plus c equals to 0. So how do we do that? So here we will say that a times lambda x2, all we have to do, we're going to replace the value of x with the x coordinate of the point R divided by lambda plus 1 and add it to b times the y coordinate of point R, so that's lambda times y2 plus y1 divided by lambda plus 1 plus c equals to 0. So here I'm going to multiply throughout with lambda plus 1, so we have a times lambda x2 plus x1 added to b times lambda y2 plus y1 plus c times lambda plus 1, that's equals to 0. So we get a times x2 times lambda, we have a times x1 plus b times y2 times lambda plus by1 plus c times lambda plus c equals to 0. So let's combine the terms containing lambda by taking it lambda as the common factor. So we have lambda times ax2 plus by2 plus c, and the rest of the terms will be ax1 plus by1 plus c equals to 0. Now, if we use equation number 1 and 2, we have already defined that equation number 1, ax1 plus by1 plus c equals 0 and ax2 plus by2 plus c equals to 0. Oh, if we substitute these two values from what is obtained in equation 1 and 2, we get lambda times 0 plus 0 equals to 0. So which tells us that the point R lies on the line. Now it's going to be a line. Lies on the line joining P and Q. That means it was a true assumption when we considered R to be dividing the line segment joining P and Q in the ratio lambda is to 1. Now this is going to be true for any point that we pick on the line joining P and Q. This means every point on the line segment which joins P and Q must lie on the first degree equation. Now if every point lies on this equation, this is the first degree equation in x and y, this only tells us that therefore the equation of a straight line is given by a first degree equation in x and y. And because every point lying on the line segment joining P and Q lies on this particular equation, ax plus by plus e equals to 0, thus we can say that the equation of a straight line is given by this particular equation, which is a first degree equation in x and y. Hence we have successfully proved our theorem.